Hello Eng 1060. In this video, we will cover debugging. Debugging is the task of identifying and correcting any errors, also known as bugs, in code. With coding, it is sometimes much more time-consuming and challenging to identify the code than to write the code itself. This is especially true for poorly written code. So therefore, good programming practices will generally reduce the likelihood of bugs. This includes functions. The modular nature of functions means that bugs are more isolated. Comments allow us to stay on track and remind us of what our purpose is. Indenting allows us to visualize the structure of the code much more readily. Pseudocode allows us to organize our thoughts and plan our coding. And lastly, descriptive variable names allow us to readily read our code and make it flow. MATLAB has a debugger tool to assist with debugging. It allows for code stops at certain points. It also allows us to step through our code line by line. This is especially useful in complicated loops and functions. Breakpoints in MATLAB represent a stop sign for code execution. Breakpoints can be set by pressing the Breakpoints button in the editor panel. And this brings up a drop list of different operations such as clear all, set or clearing breakpoints, enabling or disabling breakpoints, but also setting conditions. Valid breakpoints will appear as a red circle in the code. Grey circles indicate that there is a syntax error or that the M file is currently unsaved. And conditional breakpoints appear as yellow circles. When setting conditional breakpoints, a dialog box will appear where you can enter your condition. For this particular example, I have set the condition that savings less than 0. This breakpoint will only activate if the condition is true. We can also set breakpoints by clicking the line next to the line number. Left clicking will set an unconditional breakpoint, so a red breakpoint. Right clicking will give you both breakpoint options. So here we have the red breakpoint, which is the unconditional breakpoint. And here we have the conditional breakpoint, which is the yellow breakpoint. Conditional breakpoints only stop the code if the condition is met. In the previous slide, I set this breakpoint to be savings less than 0. For this example, we will know that there is something wrong with the code if our savings go into the negative numbers. So what happens is MATLAB will run your code as usual, and once it encounters a breakpoint, several options will appear. At the breakpoint where the code stops, you can either continue running the code until the next breakpoint using the continue button, or you can step through to the next line using the step button. You can also step in and out of functions and loops. So once you've hit a line which contains a function or a loop, you can step in and out using the step in and step out buttons. You can also run the code to the current cursor position using the run to cursor button. And finally, you can exit the debugger mode using the quit debugging button. So in summary, debugging code can be a time-consuming process. Ensure that you adopt good programming practices to decrease the likelihood of bugs. And use the debugger tool to step through complicated code line by line. This allows you to manually check whether the answers are valid and reasonable. As a final thought for this video, do conditional breakpoints check the condition before or after running the line that it's set at?